All right. You, Brady, how far is A from B?
5.
How did you get that?
Squares.
Okay, you counted the squares. Okay, that's beautiful. Is there anything else you could have done with these numbers to get 5? What? Is there anything you could have done with these numbers to get 5? Oh, 7 minus 2 got us 5. Interesting. Okay. Now, how far is A from C? 7. Okay. Interesting. If I take 8 minus 1. Okay. So now, how could we find this hypotenuse? So you had 25 plus 49 equals x squared. So did you get that that distance is the square root of 74? Oh, are you okay with 5 squared plus 7 squared equals x squared? Okay, and are you okay with 25 plus 49 equals x squared? Well, 25 plus 49 is 74. Right. Okay, so what I want you to do, I want you to turn to page 18 for me. Leave this little cute half sheet out. Okay. Okay. I want you to turn to page 19. I'm sorry. We're going to go to page 19. Page 19, people. Page 19. Okay. So, maybe I should go to page 19 also. Okay. Our goal is to be able to find the distance between 2 points in a coordinate plane. Now, there are 2 different ways that we can do that. Okay. They both involve the Pythagorean theorem. All right. Let's look at number 1 up here. Okay. I want to find the distance between 2 points. What did we do in this discovery activity? Okay. We created the Pythagorean theorem, correct? Okay. Well, what is drawn right here? If I made a right triangle, what are we going to make that? A leg, a hypotenuse? Okay, so let's do this. Let's make a right triangle where I create the legs. And I'm going to solve for the hypotenuse C. Hey, does this look like what we just did? Yeah, it really does. Okay, so let's count. This left leg right here, how long is it?
So which one?
This one?
7.
7. Okay, so I'm going to put a 7 right there. How long is this leg? All we have to do is count the squares. This is 6. Okay. Well, now I have a right triangle. Okay. Where we could use a squared plus b squared equals c squared. Okay. All right. Well, I'm going to make 6 my a and 7 my b. And we don't know c. What I really love right now, I really love that some of you are just like finishing this ahead of me. because you are so confident in your Pythagorean theorem skills. I love that. Okay. If you're not one of those people, that's okay. We'll get there. Okay. What is 6 squared? 36. What's 7 squared? 49. Okay. When we add 36 and 49, 85. Okay. So now we know that our last step is to take the square root of both sides. Is 85 a perfect square? No. So we're going to leave our answer as the square root of 85. If it were the square root of 81, we could say that it's 9, but it's the square root of 85, so we just know it's a little bit longer than 9. Okay. All right, for number 2, what I want you to do is draw the triangle and stop. Does your triangle look like this? Okay. How long is this leg right here? Oh, that's so cute. How long is this leg right here? 8? You agree? Ooh, it's 9. All right, you find me the distance. You find me the hypotenuse, please. You already know it, Brady?
I do.
Oh, I love it. You guys make me so happy. Check in with your elbow partner to see if they get the same thing. Your square root. Square root of 82. Okay. Denise, what'd you get for your answer? Square root of 82. Denise got the square root of 82. Give me a thumbs up if you agree with Denise. Okay, we have 1 squared plus 9 squared equals C squared. Okay, this is what I'm noticing. A lot of you are trying to give me the answer of 82. It needs to be the square root of 82. Do not give me 82, give me the square root of 82. Okay. Okay, oh my gosh, a number 4, I can't make a triangle. How do I determine the distance?
Number 4.
What's the distance between those 2 points? How far is this point from this point? Hey, if it's vertical or horizontal, we can just count the squares, okay? Don't panic. It's already vertical. We can just count the squares. All right, well, now you see down below, I'm giving you like coordinates, okay? So like in 5, 6, 7, and 8, I'm giving you coordinates, okay? I'm not gonna have you graph them. We need to be able to find the distance between these 2 points without using a graph, okay? So up here, I want you to write that we're going to find the distance between a coordinate that we call x1, y1, and a coordinate we're going to call x2, y2. This is just like coordinate number 1, coordinate number 2. We're going to find the distance between 2 coordinates. Now, we've done that on the graph by creating a triangle and using the Pythagorean theorem. Okay. but I'm gonna have you just like drop your pencils for a moment and we're gonna look at that cute little book that we were making. Okay, I'm gonna come back to this guy. Okay, now what's gonna happen is I am going to give you two coordinates in the coordinate plane. Okay, so you're not gonna get like any of this. Okay, you're just gonna get, hey, here's a coordinate at 1, 7, and here's a coordinate at 8, 2. All right, well, let's talk about how we got those numbers of 5 and 7. Okay, 5 came from the difference of 7 and 2. What do I mean by difference? We subtracted them. Okay, 7 came from the difference of 1 and 8. Okay, well then what did we do with 5 and 7? We squared them and added them together, and then at the end we had to take the square root. Okay, so the distance formula comes from the Pythagorean theorem. We just don't actually draw out the triangle. Okay, so this is what the distance formula does. It takes the difference of the x's and the difference of the y, just like we just talked about. Okay, and it puts them into the Pythagorean theorem, a squared plus b squared. And then to solve at the very end, we always have to take the square root of that number. So the distance formula is just one formula to where we don't have to set it up and like add things together and solve for x. It's just we're gonna put in these missing pieces and get a number. Okay, now I could imagine that maybe this is a little intimidating, this formula. Okay, so to help you, I have a little fill in the blank here.
There you go, JJ.
This document is going to help you on both our notes and your homework. It's a lot. Just take a deep breath. Okay. So here we go. In number 5, we're finding the distance between 0, 0 and 6, 8.
Yeah.
Okay. So this is what we're going to do. We're going to go to our distance formula sheet here. All right. So letter point A is 0, 0, and point B is 6, 8. So this is what we do. And maybe it would be a good idea to say that this is number 5 from our notes. Okay. So now we're just gonna fill in for our formula, okay? x2, so that's the x coordinate of our second one. What is it?
6.
So I'm gonna write that here. Minus the x coordinate from our first point. Okay. Okay. y2 minus y1. So we're going to choose the y coordinate from our second point minus the y coordinate from our first point. Okay. So notice these both are x's. These both are y's. Okay, now we just have to do the math. So we need to do the subtraction first. What's 6 minus 0? What's 8 minus 0? Cool. So now we know 6 squared is 36. We know 8 squared is 64. So from here to here, we need to take those squares, just like we would have in the Pythagorean theorem. Bennett, what do we need to do now? Now we need to add them together. We need to take 36 plus 64, which is. Do I want you to write that the distance is the square root of 100? If it's a perfect square under there, I want that distance to be 10. That's your answer. All right, let's do number 6. Okay, so number 6, we have the coordinate r is negative 2, 3. And we have the coordinate s as 3, 15. All right, so I'm going to fill in. X2 is 3. X1 is negative 2. Y2 is 15. Y1 is 3. Can you okay. Now I need you to be careful. We're taking 3 minus negative 2. What happens when we take 3 minus negative 2? It turns to 3 plus 2.
Oh wait, that's what happened.
2 negatives make a positive, people.
2 negatives make a positive. Negative. 3 is negative.
Okay, 3 minus negative 2. That's like our keep, change, change. Keep, change. So this is 5 squared. And this is 12 squared.
So it's 5. So when that happens,
Mm-hmm. Okay. So, Brady, if we have minus a negative, that's when we have to do our keep, change, change and turn it into plus a positive. Okay. So this is actually 5 squared and this is actually 12 squared. Okay. Well, 5 squared is 25 and 12 squared is 144. So we have the square root of 169. What's the square root of 169? 13. Okay. Now, this is what I want you to do. I want you to go back to your notes. And I want you to transfer this onto your notes. So I want you to write every piece of this. so you can see what it looks like without your little step-by-step worksheet.
They throw all that on there.
I would like you to, yes.
I don't feel like writing all.
Oh my
God.
I would like you to write the whole thing, please.
Is our homework gonna have like a small map?
Just take a deep breath.
You want us to write number 5 on there?
I won't make you. Okay.
Appreciate that.
What I do want you to do, however,
Keep going. She just made all this. You. There's no. I can just. Miss Holman, be for right now. You just made us write that. She's not gonna write it.
I want, what?
Jada, write.
What did you just say?
There's no copy and paste. Jada,
That is not what my ears heard.
You're
Okay,
supposed to write it down.
I need you to write it down. What I would like you to do now, I would like you to find the distance between the points and number 7. You can either use the chart, use that gold chart to help you, or you can write it in your notes using the steps from the gold sheet. You decide.
Ow. Cordell, do it. Do like fold. Do you ever comb your hair? Yeah. 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 So, yeah. What's wrong? Right. Yes. Bro. Oh my God. Oh, 1, 2, 3. So we add to, right? What, Bennett? What? Change. Flip. What?
I just wanted to do number 7.
Gotcha.
You deep breath. Ooh, Bennett got a really nice answer.
That's what I like to see, JJ.
I'm good. That's what it sounds like. Can you say it?
Can I use this? Like,
Wait, Miss Holman, you can flip on it.
On the wires? No, on the wires.
Only on one.
Yeah. Okay, when you set up the distance formula, it should look like this. Do you have 9 minus 1 squared? Plus 13 minus negative 2 squared? Okay. When we do 13 minus negative 2, okay, 9 minus 1, you should have 8 squared plus 15 squared. Ooh, this is nice.
do you really not right?
Yeah.
Wow.
I know.
That's crazy.
So we have 64 plus 225, which means we have the square root of 289, right? So our distance is 17. Woo! Okay, here's our homework. Turn to page 20. Your homework is page 20, and guess what? On 1, 2, 3, 4, you can use the back side of this sheet. On 5, 6, 7, 8, who do we appreciate? On 5, 6, 7, 8,
Don't say that, Miss Holmes.
what do I want you to do on 5, 6, 7, 8?
Use your resources.
Make a triangle for the Pythagorean theorem.
What if you can't make a
Okay.
triangle? How do I make those? How do I make them? Do this?
Yeah, just like that. Yeah, that's beautiful.
What's this one then?
That would be great.
64
Just like
plus.
Yep.
What's 64 plus
And then this one?
49?
Yep, just like that.
64.
You can do that. Yep.
Where do I go?
Up.
Shut up.
Ah. That's not up.
Oh.
Like you
I'll
could go
say
all the way up to here.
Oh,
and then
yeah. And then this one?
What?
that you can make a triangle. You can just
You're such a smart. Random letters.
What?
For one thing, we'll just put random letters.
Sure, you can just call them all AB.
Let's go.
So if the negative's first, no. If the negative's second, yes. So this is -1 minus 7. So that's -8.
Can I use this as my evidence for tomorrow when I turn it in? Or show you?
Nice. Thank you, there, Brady.